Yeah, it should mean all this stuff right here. Less than, greater than, less than or equal to, greater than or equal to. And that'll change a few things about how we do this, but not a ton. Okay? It's basically we're going to be graphing these lines in the exact same way that we've been doing it, except at the end there'll be just a little something different. So we're going to start off by kind of the same way we always start off, by reminding ourselves how we check things. So number one says determine whether each ordered pair is a solution of x plus y is less than or equal to 6. So how is it that we usually determine whether something really is a solution? How do we check an answer? We always plug in, right? So I hope you're seeing that theme. We have done that a lot. So the point 0, 4. So they're basically asking us, is 0, 4 a solution of this inequality? So I'll do this first one with you. This basically means that x is 0 and y is 4. So to check this, I would write 0 plus 4 is less than or equal to 6. And of course, 0 plus 4 is just 4. So 4 is less than or equal to 6. Is that true? Is that really the case? Is 4 less than or equal to 6? Yes, that is true. Sometimes people get hung up and they say, but it's not equal to 6. Keep in mind that the word is not less than and equal to. We don't have to fulfill both of those. Both of those don't have to be true. It's less than or equal to. And 4 is less than 6, right? And so 4 is less than or equal to 6. And so why don't you guys try B, C, and D real quick. See if you can determine whether those points are also. So the answer to letter A is yes. Let's see if you guys can figure it out for B, C, and D. So B, we plug in with B and we get negative 3 plus 1 is less than or equal to 6. So when you do a little arithmetic there, you get negative 2 is less than or equal to 6. So is that true? So yeah, we say yes, that is a solution. With letter C, we write 9 plus negative 2 is less than or equal to 6. That gives me 7 is less than or equal to 6. Is that true? No, it's not. And so that means that 9, negative 2 is not a solution to this inequality. So far, they have been, but with C, the answer is no, it is not a solution. And so the last one, negative 1 plus 7 is less than or equal to 6. Negative 1 plus 7 is 6. Is 6 less than or equal to 6? Yeah. Yes, it is. So that means our fourth point is also a solution to this inequality. And with most of these inequalities, there's going to be an infinite number of solutions. So we can't possibly list all of the answers, right? We can't possibly list all of them. And so we're going to represent the answers in kind of a different way. It's actually going to be a graphical way that we do this. Before we do that, though, do you guys have any questions at all? Did you all do well? Yes, yes, no, yes on the answers? Okay, good. All right, let's take a look then at number 2. And this is where we'll get into graphing. I want to do this one with you, then I'll have you guys do a couple of these on your own. So this says graph the inequality, and it lists out 3x minus y is less than or equal to 6. So right now, we really, we have a choice about how we could graph this. I think we have 3 different ways to graph this. The way that you guys came to school as freshmen, most of you would say, hey, slope-intercept is the right way to do it. But there are other ways. There's point-slope, like the one we just talked about. There's also finding intercepts. That would be another way to do it, right? What do you guys choose? You want to do slope-intercept? You want to do finding intercepts? You want to do point-slope?
Point-slope.
Point-slope. It's not really in point-slope form, though, is it?
No. Just kidding.
Do slope-intercept.
Slope-intercept would be fairly easy to do. Intercepts would be fairly easy to do. You guys said slope-intercept, so let's be very careful with how we do this. Slope-intercept needs to be y equals mx plus b. And we fully understand that it's going to be less than or greater than or something, but we need to solve for y. What would you guys do first if you're going to solve for y? Yep, we're going to subtract the 3x off of both sides. So that would give us, be really careful with this. Sometimes people will lose the minus sign that's on the y there. Make sure we don't lose that. So we're going to end up with negative y is less than or equal to 6 minus 3x. Y is still not by itself. What do I need to do? Divide by negative 1. So when I divide both sides by negative 1, I get y. But I just did something really important, and maybe we can make this connection from the past. Whenever I divide by a negative number, I got to take that inequality and flip it around. Remember that from whenever that was, last chapter? So this becomes y is greater than or equal to negative 6 plus 3x. Okay, so from this, you guys said let's do slope-intercept form. From this, we should be able to figure out those two pieces of information. We should be able to figure out the slope as well as the y-intercept. So what do you guys think the y-intercept is for this particular line? And let's remember to always try to write that as a point, 0, comma, negative 6. And what's the slope? 3, yeah. And might be wise to write it as 3 over 1, just so we can clearly see the rise and clearly see the run. Does that make sense? I'm getting my y-intercept from this. I'm getting my slope from that. Okay, so of those two things, the slope or the y-intercept, which one should we put on our graph first? No, it's the negative 6. We want to graph the y-intercept first because we know that that is a point that's on the line, and then we'll base our slope from that. So 0, negative 6 is, let's see here, 1, 2, 3, 4, 5. I got that right here. And then I'm going to count my slope off. So I'm going to go rise 3, run 1. So up 3, can you see it in red there? Yeah. Up 3, right 1. That'll give me my second point. Question?
So you always go this way if it's a positive, and then you go that way if it's a negative?
Yeah, you could think of it that way. The way that I think about it is that this is a positive 3, and this is a positive 1. So positive 3 would be up 3, positive 1 would be right 1.
And then if it was like negative 3 over negative 1, then you would go left 1.
Yeah, down 3, left 1. Exactly. Yep. And in both cases, it's still a positive 3, right? Yeah. Okay, I'll do one more just for fun. I could also go up 3, right 1 from that point. And that would give me a third point right about there. So I am going to connect these 3 points. These 3 points are all on my line. And I'm going to connect them. And I'm going to connect them with a solid line. You're going to find out soon that sometimes we won't use a solid line. So here is my solid line. Something like that. That make sense? You know what I'm going to do? Let me actually erase that. I'm going to do... I'm going to try to use the whole graph. So something like that. We good?
Should we do that too?
Yeah, go ahead and definitely you want to put the line in there.
No, but like through the whole graph?
Extend it as far as you can. Yeah. Okay. So here is where we're going to do something kind of unique. And that something unique is shading. Have you guys ever done this where you shade one side of the line? Okay. Can I explain why? So I've got this original equation up here. I'll highlight it for you. It's right up here. I've got this original equation, and it's 3x minus y is less than or equal to 6. And like we proved before, there are lots of points that will satisfy this linear equation. Lots of points that will work. Can I give you an example? I'll give you an example of a point that would work. Like if I tried to test out the point 0, 0. If I tried to test it out, I would plug it in just like we did a few minutes ago. It'd go, 3 times 0 is, and 0 minus 0 is less than or equal to 6. Well, is 0 less than or equal to 6?
Yes.
It is. So that means 0, 0 is a solution to this inequality. But isn't 0, 0 not even on the line?
Yeah.
It's over here. It's not even on the line. We could try some other points that I think would work. Like what if we tried, instead of 0, 0, what if I tried the point 0, 1? So that's up here. if I tried the 0.01, wouldn't I end up with
Yeah,
3 times 0 minus 1 is less than or equal to 6?
and that's true.
And that's true too, isn't it? So there's all these other points that are not even on the line that fulfill the inequality. And so the way that I would represent that is with some shading. So it would look something like this. I'm going to shade over here. Let me try that again. I'm going to shade over here,
That whole side of
that whole left side. The reason why I'm going to shade over there is because I tried out a couple of test values over there, and they proved to be true, didn't they? They proved to be true. So what that means, and you could test this out to your heart's content, if you got a couple of hours and just feel like spending a couple of hours, you could take all the points in that shaded region, and you could test them out one by one in your original inequality, and all of them would work. Every single one of them. Now, by the same token, you could take all the points down here. We could do an example of this. You could take all the points over here on the right-hand side, and none of them would work. So let me give you an example of that. So if I did, maybe if I tried, can you guys give me an example of a point that's in the non-shaded region?
-4, -8, or -4, -3.
No, I think that's -4, -3 is like right there.
2. I mean, sorry.
4, 0?
4, 3.
So 4, 3, 4, 0. 4, 3 is pretty close to the line, but 4, 0 is definitely right here, isn't it? 4, 0 is definitely not in my shaded region. So let's try that out. So I would go 3 times 4 minus 0 is less than or equal to 6. Well, 3 times 4 is 12, and 12 minus 0 is 12. 12 is less than or equal to 6? I don't think so. So that's not true, and that makes sense, doesn't it? Because 4, 0 is not in my answer region, and so it shouldn't work. The way that you determine this is kind of like what I did at the start, is you test out a point on either side of the line, and if that point works, right, if it produces a truth, then that must be the answer region. But if the point you tried out produces a false, then that's probably not the answer region, it's probably the other one. Make sense? Yes, ma'am.
So like on a quiz, do we have to shade that until we just do the line?
Yeah, good question. So on a quiz, what would I expect? I would expect to see the correct line, like you said, and the shading. You definitely need to do the shading. Now there's some things you can do here. You could do this, like if you, for instance, like let's say you, I don't know, for some reason you're averse to shading, and you'd rather not do that. You can get by other ways. I mean, I think it's pretty easy just to shade one side. Now, if you're using a pen, you're certainly running the risk of shading the wrong side and be like, oh, I need to change my answer, and then it turns into this really awful mess. So one of the ways that you can get around that is you could just label your region. Like you could say, this is region A, this is region B, and you could say, answer A, or region A is my answer. You could do it that way too. In fact, a lot of times like on a quiz or a test or multiple choice or something, I might have stuff like this, and I might label the regions A, B, C, D or something, and you say, okay, the region A is the answer. So that would be fine too. Yeah. Okay, any other questions? These are all really, really good. Okay, fantastic. Let's do one more. I realize there's more than that, but let's do one where you guys can try this on your own. Yes. I want you guys to try this. Definitely try this with your table partner. I want to say there is going to be one thing that you may or may not know how to do on this one, and it's based on this. Did you guys notice with number 2, the inequality was like less than or equal to, or it was greater than or equal to? Notice how this one does not have the or equal to on it. That's going to change a little bit of something with your line. We can talk about that. But for now, why don't you guys give this one a shot? I don't know what method you want to use. Slope-intercept would work fine. Maybe that's the right way for you. But give it a shot. You decide. Work with your table partner. I'll give you 4 or 5 minutes to give this one a try. Ready, set, go. Let me help you with the little twist on this one as far as what we do with this line. Did you guys use slope-intercept?
Yes.
Okay. Slope-intercept is fine. You could do intercepts too. Slope-intercept would look like this. You'd subtract 6x, so you'd get 5y. is less than 10 minus 6x. Then you divide by 5, and when you divide by 5, you get y is less than 2 minus 6/5 x. Make sense? Any questions? You all look pretty calm. Yeah, go ahead.
Never mind.
Are you sure?
Yeah.
Okay. Okay, so from this we should be able to get the y-intercept, and we should be able to get the slope. So, Sam, what's the y-intercept?
The y-intercept is 2.
Yep. So y-intercept is 0, 2. So I'm going to graph that first. So 0, 2 is right there. And then we need to count off our slope, right? So the slope in this case, anybody would be? Negative 6/5. Yep. So slope is negative 6/5. So we count off our slope. Negative 6/5 could mean down 6. So let's see, I'll do it like this. Down 6, so down 1, 2, one more, something like that. Right 5, so 1, 2, 3, 4, 5. And this would be my second point right about there. You guys all have something like that? You could reverse the slope perhaps and go up 6, left 5 if you wanted to. I only really need 2 points, so I'm going to stop right there. So here is where, I'll let you guys figure out the shading here in a second, but here is where this line is going to be a little bit different. If you were tempted, and I would understand why, if you were tempted to draw, let's see here, something like that, I would totally understand. That would make a lot of sense. However, we have to make one little adjustment to this, and I'm going to make my little adjustment this way. Because the inequality does not include an or equal to, what we have to do with this line is we have to turn it into a dashed line or a dotted line. Remember, the or equal to means that it includes the endpoint. Remember, you guys remember with those inequalities we did where the little circle was either filled in or open?
Yeah.
So a filled in circle would be like a solid line like we had on the last one, but an open circle would be like a dotted line. So what I'm going to do is I'm going to take this line and I'm just going to turn it into a dashed line or a dotted line. I don't know if I like that. Let me change that a little bit. There we go. See how it turned into a dotted line? What that means is that the solution goes right up to the line, but doesn't include the line. And the reason why we do that is because there is not an or equal to on the inequality. It's simply less than. Okay, so I'm going to let you guys figure out the shading if you haven't already done that. Use a test value. What's often the easiest test value?
0,
0, 0. That's the first one I used last time, and I think it'd be the first one you'd want to use here. I think it would work just fine on this one. So, yeah, 0, 0 would be a wise one to plug in. So give it a shot, see if you can figure out which side the shading needs to be on. Luke, you with us this morning? Okay. If we do test that out, it's going to be 6 times 0 plus 5 times 0 is less than 10. So anything times 0 is 0. So I end up with 0 plus 0, and 0 is less than 10. Is that a true statement? Yeah, it's absolutely a true statement. Therefore, 0, 0 is in the answer region. And since 0, 0 is in the answer region, we would shade in that region, which would be over there. So kind of that lower left-hand corner would be the answer set. What do you guys think? Have any questions? Question?
Okay, so what was the equation you used to plug in the 0?
So I always tend to use the original. I'm just going to, because it's usually doesn't have fractions in it that I need to worry about. It's usually set up to make a pretty easy judgment on true or false. So but you really honestly, you could use this one, you could use that one, you could use any of those inequalities as long as they really are as long as you haven't made any mistakes.
So like
All of those should work.
So if you were to use the origin, you just do like 6 times 0 plus 5 times 0.
All I'm doing is I'm plugging in the 0 and the 0 for the x and the y.
And
and then just looking at it and deciding, is this a true or false statement?
Then it actually is less than 10. So if you find out it's a true statement, then what do you do?
Then you shade the region that had that point. So we're not done yet. We go till 35.
With 0, 0 is middle. Does it really have a region?
So we're looking in. So Lana, we're looking in regard to the line. You're really fixated on the x-axis and the y-axis, and we're not really concerned about that. We are concerned about which side of the line should be shaded. Is it so? So when I say we're testing it out, what I'm saying is, are we going to be shading region A or region? And let me make that a little more clear. Or region B. There's only two regions. One of them is on kind of the lower left side of the line. The other is the upper right-hand side of the line. And so when I test out 0, 0, I'm not really worried about is it on the x or the y-axis. You're thinking quadrants. You're equating quadrants with regions, and that's not the case on this one. I'm simply looking at two different regions, lower left of the line and upper right of the line. Only one of the two of them is going to work. And since 0, 0 worked, and 0, 0 is in region A, as I've labeled it, that means that I need to shade region A.
So can you just plug in 0, 0 all the time?
The only time you can't is if the line goes through 0, 0,
Oh, so then you have to plug something.
and you have to plug in something else.
1, 1. Yeah, 1, 1.
Something else. Something else, hopefully similarly easy to 0, 0. Question?
So, if you were plugging in like 1, 3, then we would just do 6 times 4 plus 5 times 3 or whatever.
Yeah. And then you get 6 plus 15 is 21. 21 is less than 10. I don't think so. And so whatever point that is in, yeah, that region would not be the answer. It should be the other region. Yeah, so if one region is false, the other region better be true. Yeah. So really, you only need to plug in one point and base your answer off that.